Welcome to the 7.2 video. So today's goals are, one, be able to determine when a function is increasing or decreasing, so we'll talk about that. Be able to determine the end behavior of a function. Number three, be able to locate any maximums or minimums. And then four, based on what the graph looks like, we should be able to tell what type of equation that is. And then likewise, if we know what type of equation it is or what kind of function it is, what's the graph going to look like. So let's start out with the last thing first. Based on what the graph looks like, we should be able to tell what type of equation it is. So the linear equation, that's the one that looks like the line, and you've dealt with those for many years now. So that's linear. The quadratic is what Chapter 5 was all about, and that is the parabola. And then as we get into higher degrees, so the cubic is a third degree. That one looks like an N. The quartic is a fourth degree, so that has one more change of direction than the cubic. See, this one changes direction 3 times. This one changes directions twice. And then the quintic is the one that looks like an N with an extra hump on it. So linear, that one is an x squared type, just an x equation, like y equals x. Quadratic is going to be an x squared. Cubic is an x to the third. Quartic is an x to the fourth. And quintic is an x to the fifth. And then they keep going up, but we should know these 5 terms for this unit. Okay, so let's get into, oh, by the way, this would be a positive x to the third for cubic. And if it was negative, this would just be flipped upside down. So instead of starting out pointing down, it would come down, up, and then down again. So negative x to the third equation would look something like this. And this might look like negative x to the third plus 2x minus 7 or something like that. Okay, so let's get into the other things that I had mentioned. The minimum, maximum. Minima is plural for minimum. That's what the book uses. You can also say minimums. That's okay. I looked it up on Webster. Maxima is maximums. So the minimums are -5, -8. And so you really only need to put the y coordinate, but we can use both coordinates. That's okay. So -5, -8. And then the other minimum here is 4, -6. So I call these the local minimums because we want to figure out where's a local low point. Granted, this is the lowest point of them all. That's the farthest it goes down. But this is also another local minimum. That's where it changes from going down to going up. The local maximum would be 0, 6. Now the absolute maximum is infinity because these go up forever, but the local maximum is that. Okay, the end behavior, since you're taking pre-calculus next year, we'll try to keep it the same there. Our book says it a little bit differently, but the way you'll see it next year in pre-calculus, it says as x goes to infinity, so what that means, as x gets bigger and bigger and bigger along this line, what's happening to the y? So as we go over here, it's getting bigger and bigger and bigger. So as x goes to infinity, y will also go to infinity. Likewise, as x goes to negative infinity, so if we go this way in the x direction, the y is also going up. So y will also be going to infinity this time. Okay? And then when is it increasing and when is it decreasing? So increasing, decreasing, you want to think of it like you're riding a roller coaster. So you're going down the roller coaster, then you start going up the roller coaster, and then back down, and then you kind of go up forever. It sounds kind of not fun. So decreasing, we're going down the roller coaster until we get to this point, the minimum, and then we start going up the roller coaster, so that would be increasing. And then we get to this point, we start decreasing again. And then once we get down to our minimum, we start going up again, and we are increasing. So increasing is from, and we only use the x values here. So from -5 until we get to 0, it's increasing. So we'd say from -5 to 0. And then the other place where it's increasing is from 4 till forever, basically. So we'd say x is greater than 4. So those are the two places where this graph is increasing. Where it's decreasing is from -5 till forever in the negative direction. So it's decreasing from basically -infinity to -5. Or we could say x is less than -5. And you could definitely write from, -infinity. I'll extend the page here. If you wanted to write from -infinity is less than x is less than -5, that's totally fine too. These two are the same thing. Okay, and then it's also decreasing from 0 to 4. So we put 0 is less than x is less than 4. Alright, so that's how to describe the minimum, maximum, and behavior, and increasing and decreasing. Alright, so next I would like you to graph this in your calculator, and we're going to find the minimums, maximums, describe the end behavior when it's increasing and decreasing. So if you need time to do that, pause the video. I already have it plugged into my calculator here. So we'll look at the graph, and I'll hit zoom 6 so that we all kind of have the same window. And I'm just going to sketch this on my notes. So it looks like it dips down. So there's our x and y axis. That looks very pretty. And then it looks like it goes something like this. So we're going to find this minimum, this maximum, and then we'll figure out the increasing and decreasing stuff. So the minimum, if you recall, we go second, the trace button. Minimum is the third one. And then left bound, we just want to make sure we're on the left of that minimum. Maybe one more. Hit enter. Right bound, make sure we're on the right of the minimum. Hit enter. And then guess, you can just hit enter. So it looks like our minimum is -0.3 and then -2.3, and we'll round it. So -0.3, -2.3. That's our minimum. And then our maximum, we'll hit second, trace, maximum this time. And left bound, you want to make sure you're on the left of that maximum. Looks like we are already, so we can hit enter. And then right bound, we'll just arrow over until we get to the right of that maximum. That looks good. Hit enter. And then guess, you can just hit enter. So the maximum is 2.3, 6.3. So 2.3, 6.3. Okay, so we've got the maximum, that's 2.3, 6.3. The minimum, we did that. The end behavior, we'd say as x goes to infinity. So as x gets positive, the y is getting negative. So y will be going to -infinity. And then as x goes to -infinity, so as x gets negative, y is getting positive. So y goes to +infinity. Alright, so there's the end behavior. When is it increasing? So it looks like as we ride our roller coaster, I'll change colors here. We're going down, so decreasing, and then from here to here we're increasing, and then we decrease forever. So that would be a fun roller coaster ride. Okay, so for increasing, it's from negative 0.3 to 2.3. And then for decreasing, it's decreasing in 2 spots. That would be from negative infinity to negative 0.3. So we could say x is less than negative 0.3. Or from 2.3 on forever. And so we would say x is greater than 2.3. Alright, so that's it for today. Your assignment is on page 438. And we'll go over this in class.